external guest. Ooh, there we are, there's the mic. Cool, this is going to be awesome. I'm really looking forward to this. We have really exciting talks coming. And I'd say that we actually start with Pitt, who is going to present API testing. Pitt, welcome up.
Hello, and welcome. Do we get the screen? Welcome to my tech talk on API testing. So first, I want to talk about why do I even talk about API testing here? Because it's not a fresh new topic and super hypey like a GESHDO kind of way topic, but I think it's still a very important topic for all of us to provide good code. And I haven't done it myself enough in the past, so that's why I'm kind of want to look into it deeper and really want to do work more and more on testing. And to visualize a bit, I made a small example of how we build code. So when we build code, we usually start off with a few components, and it's very simple and easy to manage. And then we start adding some more components, and it gets a bit messier, but still like on a manageable level. We maybe still feel fine about it, but it gets messier and messier, and then just increases over time. And basically, with more people involved and with bigger size of application, it's getting harder to manage that we have a good quality of code if we don't do proper testing. Yeah, so as an example there, I just wanted to say if code errors occur somewhere here in the code, it's usually very hard to spot now where this actually happens, because especially if different people are involved, if I'm basically responsible for some bug here, because I did some changes and someone else is working on something else, and suddenly, because both of these things happen at the same time, we have some bug, maybe each of us don't really know why it is happening and where the origin of the bug really comes from, and we basically are just searching and searching and cannot really find the bug that easily and just try to do workarounds. So that is what I list here kind of as a main potential problem of such an application, or of any kind of application that isn't really tested enough, is that we have a hard time to find where the origin of a bug comes from, because we have obscure dependencies. Like, we don't necessarily know in this picture here how this might relate to this part of the application. So we kind of want to figure out, basically, through testing, that all the parts that we know already, how they are working, that they are working as we expect them to work. And these problems basically just increase more with the size of our team and the size of our application over time. So what we rather want to have, though, is like a very structured application where we know exactly what is happening, and yeah, can easily test basically what is happening in each of these areas and know who's responsible for what. So these are kind of the main goals I put into for testing. What we want to achieve is the main thing. We want to ensure quality of our code to make it easy and maintainable. And we do basic manual testing already when we develop any kind of code usually, because when we develop something, we usually go into the code afterwards and say, okay, let's check if that actually works, because otherwise it would be very risky to put anything like that into production. But the problem with, like what I said earlier, with obscure dependencies, that we don't really know what parts of our application are working together. So if we have a big application and we do some changes in some part, and we don't know that there's actually dependency on this and some other part of the application, and we might just test what we actually changed, but haven't really tested any of the other stuff, then there will be suddenly errors, maybe in production even, that have not been detected during the development phase. So that's why we want to test basically everything all the time, but doing this manually, testing all parts of our application manually, is just a very tedious task and not efficient. So we want to automate our testing, which in the long run is saving us time and resources to provide better code quality. But we basically just have to balance what we focus more on, like time or code quality. And it is also giving, I call it some sort of a building plan for our application. So it's a documentation of what is supposed to happen in our application. Because, yeah, usually other documentation often goes stale really quick, like in Confluence, for example, because it is not directly connected to the code. But on tests, when we have the most recent tests, we can basically always run them, and they check what the current state of our code is. And hopefully, they always run through successfully, and if not, then we should fix either the tests or the code that is affected. Yeah, so this is just a main introduction of why I even want to talk about testing, I guess, and why it is a topic worthy. I now want to just talk quickly about the different kinds of testing that exist. And I want to start with like unit testing is the main kind of testing, which is just testing the smallest module basically of an application, which we already had a tech talk from Jesper Stolz about a year ago. So feel free to check that out. That was on front end, but it's basically the same principle as on backend or on any application. After unit testing, there comes integration testing, which tests the integration of multiple modules within our project. And after integration testing, there comes system testing, which tests the integration of the entire system and checks it against as well the functional workflows, the business specifications, as well as the non-functional properties of application, for example, like accessibility, usability, performance, and so on. But the part that I'm actually talking about is called end-to-end testing, or sometimes acceptance testing, which I'm going to present today, which I'm going to do here with Postman. And this is the step after system testing even, and it checks basically for the real world use cases. So yeah, just in this picture, basically, it is kind of like system testing, and it's sometimes a bit obscure, the definition of both of those, but it's basically without any knowledge of the system, and we just test it from outside, basically the API, without any attachment to the code, really. And this basically leads to, or it basically aims to imitate the stage, the production stage of an application. So having the exact same environment as we would have in production, and therefore also test integration of external services, so any APIs or other services that we call within our application, which are not tested in the other workflows. And as I said, black box testing refers to having no knowledge of the application, like integral structure of the application, but just testing the business specifications, like based on the business specifications that we have for our project. All right, so this is what I want to present now, and I have a small demo prepared for this with a test project that I created. And this test project, I just want to show you real quick, is just a small API called GESHDO Smoothies. And the business logic of this API is basically we have two parts. We have the smoothie catalog, which contains all the smoothies, where we have the get smoothie call, which anyone can call who enters the store, basically. Then we have the creation and deletion of smoothies, which can only be done by admins. And then we have smoothie bookings, which can be done by any kind of authenticated user. So this is just a business logic behind this smoothie store to understand what kind of tests I might want to do. And I want to do these tests with Postman. So for most people are probably already familiar with Postman, but for people who are not, so Postman is an API testing user interface. So it offers an easy interface to create tests like against an API. So any kind of like get, post, put requests that you have a hard time recreating manually, like in a browser or something. It's a bit clunkier. So to just show you how you check a request in Postman, I just want to create one demo request and then show you a demo collection that I created and quickly go through what it's supposed to be doing. So what we want to test here, because it's the easiest endpoint, is the GetSmoothies endpoint that is just without any authentication. So you can create a new request here, and then I just call it GetSmoothie for now, because that's what I want to test. And since I prepared this a couple of times, I already have this here prepared, so this is just calling the endpoint GetSmoothie. Is this big enough, by the way? All right, so now what I want to do is I want to actually not just call the GetSmoothie endpoint, which we can do right now, which just gives us the basic response, and the database is empty right now, so there is nothing really fetched. But I want to fetch check for a negative response, so I actually write here in my test, which I usually fill with the information of how I basically create the test. So I say with which kind of data I'm testing and what I expect as a response. So I'm going to say with an invalid query parameter here, because this I know is going to lead to a negative response. So this is a query parameter up in the URL. So I just call it pasta, which is just a random parameter. And now I also write in here what I expect as a response. So I expect an error from this. And since I tested this a couple of times, I know that the error is called unknown query parameter. So this now describes for any kind of testers or developers in the future also what this test is actually aiming to do. So when they come in here again, they don't have to guess what is happening, but rather can try to just read it and understand why this is happening. So when I run this now, I actually do get the response, a negative response here that says unknown query parameter pasta. But at this point, this is still just an experimental test where we just go in and try it out, and it's more like manually just testing out the endpoint. But what we want to do here is basically automating it, right? So we want to have checks that actually say, yes, okay, this was successful or not successful. So what you can do here in Postman is go into the tests tab and then check for specific responses basically that this responds what we expect it to respond. So Postman offers a couple of snippets here to make that easier, but I increased the size a bit too much. So I want to check for a status code firstly, which is 400. Then I just want to check that we have a quick response time of almost 200 milliseconds. And then I want to check that the error message is actually correct. So I'm calling this also correct error message. So this is not actually a check in any way, but this is just for future testers also to know what kind of test is happening here, so they have an easier time understanding this. And now the structure of where the error message is, we could either see here in the response or also in Swagger here it's defined that it's in error message, there is the error message. So I'm going to type error message and type the error message here. Oh, I guess there's a mistake, but I guess we can also just show that there is a mistake. So now what we see here is there's a test results tab that shows 2 out of 3 tests are successful. So we see the test code, the status code check, the response time check is successful, but the message check is actually not successful because I have 2 errors, it seems. I guess I'm a bit too nervous. So unknown query parameter. Okay, there's still parameter. Okay, and now it says the correct message. So I basically just want to check that this is exactly what I expect, that all these things return the things that I expect of them. So now I would basically, if I want to create this for this entire application, I would want to create tests for all these kind of endpoints and all workflows that I can come up with from our business perspective. So since this is a bit too long of a task to do within the demo, I prepared a collection here. So a collection is basically just a collection of tests that are running within the order that I'm giving them. And as I said quickly in the business specifications, there are 3 different types of users. So there's a user that's not authenticated at all. We have the common user is just authenticated but doesn't have any further rights, and then we have the admin user. So, so as an example here, in the non-authenticated user, I also check for if they want to order a smoothie, for example. I would expect them to get a 401 as this response, which says here authorization had not required because they are not authenticated. So they haven't authenticated at all. And for the common user, if they would try to create a smoothie, for example, they are authenticated, but they are not allowed to actually create a smoothie. So I would expect the 403 response. So I want to check that if I'm just a common user, I'm actually not allowed to create smoothies, that we don't have any missing permission checks in our code. And yeah, because I talked about a workflow earlier, because these are basically just checking the endpoints for one specific thing. Down here, I just thought of some random workflows. So a smoothie basically has a stock here in its structure, and this stock is saying basically how much of this smoothie is in stock. And if the stock is empty, then you should not be able to book this smoothie anymore. So what I'm doing here in this test then is I'm booking this smoothie. I can actually show you the smoothie first. So I need to initialize the database first because it was empty before, so I created a script for this. And then I'm just fetching the get endpoint now with the smoothies in here. And we have the Cabana Cow smoothie, which is a wonderful banana cacao smoothie. And we have 4 of them in stock. So basically, once I want to book a 5th smoothie of Cabana Cow, it should give me a response that I'm out of stock for these smoothies. So that is what I'm trying to do here then. At first, I'm trying to book 1 smoothie as a common user. Then I book 2 smoothies here as an admin user, which is basically also just another common user in this case. And then I book another smoothie again here. And then I try to book another smoothie again, but this would be basically the 5th smoothie that I book. And this should respond with that you're no longer like this, that this smoothie is out of stock and that you cannot book it. So now I can basically run this test by running this collection here, by clicking on it and then click run. And this will run all these tests here in this order. The deletion tests are just a cleanup, basically. So then I click just run. The query is on the right side, which is the default settings. And now this basically just shows me that all these tests have run successfully. So the first 3 were booked correctly, but then the 4th one got a response that we're out of stock. And now I just want to show that, because yeah, you wouldn't, like when you do changes now, what I said earlier, you would want to always test everything that we have in the application. So basically every time that we do some change, we would to test all the existing workflows already. And that's what we can do with running the entire collection from the top level, which just runs all the things that we have already. Before I do that, I need to clear the database. And I'm just going to run this to show you that this is running through successfully, hopefully. So this is now just going through all the tests that we have in here in their order. And now it says 152 tests have successfully passed and 0 of them have failed. So that it seems to be in a good state right now. But if we do any further changes, we can just run this again and see that all the existing workflows are still working as expected. All right, so this was it for the demo. So I just want to really quickly recap on Postman, on the demo in general, and on testing. So Postman, I think, is a good tool to start with for API testing because it allows especially easy experimental testing to just test out some endpoints and also creation of these collections and some testing workflows. Just when it gets bigger, it's kind of not that optimal anymore. But it also has the advantage of being independent of any programming language, so we can just run it on any kind, if it's like Node.js backend or if it's a C# backend or whatever, it doesn't really matter because we just test the responses. And that also makes it basically a good choice to do this for any kind of application from another department, because they don't have to have any knowledge of what is in the code or have to know these programming language, because they just would have to work with that tool to test these endpoints. What I'm looking forward to for myself to work on also in the future in terms of testing, because I haven't done that properly yet. Because right now, as you saw in the example now, I was basically calling this collection, the entire collection, manually at the end, which is not necessarily optimal, because that would mean the developer would every time have to step into the tests and then just run these tests and check if everything is successful. Instead, it would be nice if we can integrate it in the workflow of our deployment, that automatically at the end of our deployment, or at the end of the pull request, I guess, it would check that all these tests are running through successfully and would give back a response to the developer if something has failed. That would be possible with Newman, a sub-application of Postman. Then, since the tests are growing bigger and bigger, or the size of the application is going bigger and bigger, it is probably easier to manage API tests in code in the long run. So for Node.js, there's a package called Supertest, for example, to run these API tests within the code, which could then also be easily integrated in the CI. And then test-driven development is also something I would like to start working more in, like this kind of style, which I actually did also for this application. So I developed all these tests basically first, and then I developed the final the application itself. So that was kind of nice to see that's this workflow that it feels like a bit cleaner, because I know that this is actually fulfilling now the things that I wanted to fulfill in terms of my business specification. Yeah, so just to finish up my talk, testing or API testing is generally beneficial for larger projects. If you have really small projects, it might not be really worth it, because you have a lot of overhead, but it allows easier collaboration in the team on the code, because everyone has basically this living documentation they can fall back to and just run all these checks for the code that they have. And then just lastly, I want to say that exhaustive tests don't exist. So like testing don't save us from everything. And even though if you're like a really good tester, they will not be able to find all the bugs that exist. And you should not aim for that. But it is like a tool just to help you to identify a good chunk of bugs that you have within the code. All right. Thank you very much for listening. Mm-hmm. Yep. I guess unit testing is probably the most important point to start, because it finds like all the errors that you have like in your workflow first. But it depends on kind of what resources you have. I think if you would have basically only testers available from another team, or something like you have a QA team, but you have only one developer for like 10 APIs or something, so then the developer might be overloaded with doing a unit test, and it might rather make sense to go for end-to-end testing, that like the tester team only goes for external tests of the application, basically. Yeah, I would say.
Cool. Any other questions? Casper?
In this case, very simple. I just called them basically statically user token, admin token, or what do you mean in this case, or generally if you? Okay. I mean, how I did it in other applications is that basically in the beginning of the tests, I just fetch tokens for all the kind of users that I have, and then I just store them. So if you have a user with admin permissions, or if you have a user with less permissions, it kind of depends on like if they are externally having these rights, these permissions, then I would need to fetch a token basically for all kinds of these different users. If we have it internally within our application that we have the different permissions set up, then I basically have it always in an initialization step that I run like for each of these user types, where I initialize this user as an admin user or as a super admin user, as we often call it. That, like the first thing is for Azure AD, where you would fetch different tokens. So if we have a like manager definition, for example, like for from Azure AD, then we don't have it defined anywhere within our code. So I fetch another token for this manager, and I fetch one token for another common user. And then I can give the user all kinds of permissions within the application, but the manager can only be through that one other token, basically. Yeah. Thank you.
Anyone else? Shoot.
Oh my God, I'm sorry. Okay, so the question is, yeah, when you should implement API testing. So I think, like, I like the test-driven approach because I think it gives most safety to the developer as well, or to actually be sure that you're doing the right thing and it does what you're expected to do. It kind of depends, though, I guess, on the project and how comfortable you are writing tests, or like who's working on the tests. So if there is just no resources to write the tests, I think it does make sense to just do them afterwards as well, just to make sure that if you give this to someone else, at least, they will be able to fall back to these tests and kind of try to understand at least what is happening here. So, yeah, I hope this answered.
And that kind of ties together with what you said about tests being a way of documentation.
Yes.
Yeah. Which I personally think is an awesome way to look at it.
Yeah, that's what I think so. Because it really helps, like for all the people in the team involved, basically just going back to that and saying, okay, this already gives me some information of what is happening here. So you don't have to go into like actual documentation or other stuff. This can just help you understand the code kind of on the fly.
Speaking of just that, like understanding the code, writing testable code is a challenge in itself. From your experience with this, what do you think is, how should I say, what are the traits of a code that is properly testable? What helps along the way?
I think like if you do this end-to-end testing, it doesn't really matter too much how the code is structured, as I said, because it's completely independent of what is happening in the code. But for unit testing and integration testing, it's definitely that you split up your code into testable units and pieces, so that you can mock the parts that are not relevant for you. Because if you have really big methods, you will end up having a hard time testing these things because there's just too much happening. So you have to mock basically 100 things or something to test one method, which is then unreasonable. So just, yes, splitting up, I think, as much as possible to have a very understandable code, which I think like all of these kind of go in hand with clean code principles, to have a understandable code and have everything, like don't repeat yourself, and just having the things well divided within the code.
Yeah, I totally agree. Awesome. Any other question? All right. In that case, thank you so much. It was amazing. Talk about DNS, but he's not actually going to talk. We're going to run a video. So, with that, are we ready? Very soon. Thank you. All right, let's go. Per on DNS.
So, what is DNS? DNS is like a simple database or phone book, like a physical phone book. Hello, and welcome to my TikTok. I'm going to talk about DNS today. So, what is DNS? DNS is like a simple database or phone book, like the physical phone book you had back in the days, or even like the phone book you have in your mobile phone. With standard phone numbers matching names, you have IP addresses matching domain names. Because who wants to remember all the IP addresses that you need to reach your favorite website? DNS is a pretty old technology, like a lot of things that run the internet today. But it is very vital to how a lot of things work. And the first Unix name server implementation was written in 1983, 1984. That was the application called Bind. I will now go through some common records that used today. Starting with the NS record. The NS record is a name server record. A name server is a type of DNS server. It stores all the DNS records for a domain. Usually I have multiple DNS servers. And on my screen, I will do a dig command to look up the NS record of the techtalk.geshdo.com domain. And as we can see, the techtalk.geshdo.com, NS record, and these are the name servers for this subdomain. And currently they are located in AWS. Next record is the A record and the AAA record. The A record holds IPv4 information, and if you need to use IPv6, you need to use the AAA record. This is one of the most common records used. A record usually maps an IP address to a domain name. Very straightforward and very simple. I will use another dig command here to check the A record for techtalk.geshdo.com, and you get this IP address as a reply. Another very common record is the CNAME record. CNAME is a canonical name record. It is used when you need an alias for another domain. In a sense, it's a pointer to check for information in another record. You can point a CNAME to another CNAME, but this is considered bad practice and is very inefficient since you need to do multiple requests to get where you want to go. A common use for a CNAME in Azure, AWS, GCP is to point to a public load balancer. It's worth noting that a CNAME is not a redirect. For that, you need something else. I will now make a dig command to look at the CNAME record. CNAME techtalk.geshdo.com currently has www.example.org, and that in turn is an A record which points to this IP address. Another record is the TXT record. In the beginning, this wasn't used as much, but it's become very important now, basically, or the last 10 years, even before that. But at the start, it was just a simple record with text in it. It accepts text strings at its value. It's primarily used for domain owner verification and email spam prevention. For email spam prevention, SPF, DKIM, and DMARC are used. For domain owner verification, you just create a TXT record with the specific information, which is then read by some system somewhere to verify that you own the domain, or at least have administrative control over it and can edit. I will now do a dig command for a text record. The techtalk.geshdo.com is a text record, and it currently has this string in it. This is an SPF record used in mail, and currently we have spfprotection.com, and Amazon SES. To continue the mail thing, another record is the MX record, which stands for Mail Exchange. This one directs email to a mail server. MX record must always point to another domain using an A record. CNAME is forbidden by the standard. MX record also have a priority value set. So if you have multiple MX records, each of them must have a priority set. If one record has 10 and another record also has 10, it will split all the mail between those two. But if you have one that's 10 and one that's 20, everything will first go to one with 10, and if that doesn't reply, it will go to the second one. We will now look at an MX record as well. So the MX record for techdoc.geshtdo.com currently points to this, and it has 1 as a priority. We only have 1 MX record in this domain. Another record is the start of a 40 record. This record stores important information about the domain or the zone, such as the email address of the administrator, or domain was last updated, how long the server should wait between refreshes, and all DNS zones need a SOA record to conform to the standard. I will now show a SOA record for you. So the SOA record here is automatically created by Route 53 in this case, since we are on Amazon AWS, and it looks like this. And the last record I will talk about here is the PTR record. It's a pointer record. This is basically an opposite record of the A record. And it's useful for anti-spam, for troubleshooting, and for logging. I will now show you the command. So I'm looking at 111, which is Cloudflare's DNS service. And this is the PTR record, and it points to this domain. There are more records than this available in the standard. I just chose to talk about the most used or most common ones. For this demonstration, I have been using dig. Dig is a very useful command, and it's default installed on Mac. It's installed on some Linux distributions, and you need to manually install it in Windows. There is also other commands that you can use, but first I will showcase another good command in dig, which is you can point it to a text file. And here we look up GESHDO.com, GESHDO.se, and AWS Amazon.com. And we can look up multiple domains in one command. We can also do this, which is pointed to a specific domain server, if you wanted to do that. Two other very common commands is nslookup, which is available in most Linux distributions. It's default in Windows, and I think it's default in Mac as well. Another useful command is the host command, which is default in most Linux distributions in Windows and in Mac. Another important part of a DNS record is its TTL. TTL is a setting that tells the DNS resolver how long it should cache the query before it trashes it or removes it from the cache, or renews it for that matter. The TTL is a very important part of the DNS because you don't want to have too high TTLs, because then it would take a long time for your record to be updated if you need to update it. But you don't want to keep it too low either, because that would put unnecessary strain on DNS servers as well. And there's a multitude different kinds of DNS servers. For example, there's the root server, or servers for that matter. If we look at this image, for example, we have the root servers, which keep the information of all the TLDs, which are the top level domains, like org, com, .net, SE, etc. And the TLDs, in turn, have information about domains that correlate to the TLD. So for org, wikipedia.org. For com, Google.com, Amazon.com, GESHDO.com. .net, speedtest.net. And then it continues down as speedtest.net has subdomains or sub-records, depending on how you look at it. And in my example here, I have been using TechTalk. TechTalk.geshdo.com is a subdomain of geshdo.com. So, how does a record, or how does a computer or anything really query for information? So if we look here, this assumes that nothing is cached. But your computer or laptop or server or whatever usually has a cache. The DNS servers you're asking also has a cache. But in this case, we're asking for example.com. We ask our DNS resolver for this information. DNS resolver sees that this is a .com, or rather, it doesn't know anything. So it asks the root server. Root server says go to .com, and then we go at step 4. We ask the .com TLD. We get a reply, go to this name server, and then we ask that name server, and we get the IP. The IP gets a solver to a computer, and that's what's shown for us as the end user. That's everything for me today. Thank you very much.
Emil.
Makes sense to you? Yeah, mostly.
Cool. Axel.
Yeah. So the question is if I have an IP address that we haven't configured a PTR record for it. Yeah, it's required. You need to configure a PTR record for it to actually work. So it's something you do deliberately to be able to do a reverse lookup of the domain.
Cool. Axel again.
So why the usage has increased of ReactiveX in the last 10 years? Well, mostly it's because we use a lot more internet today. And also all the cloud providers usually use the TXT record for domain verification. So if you want to set up a cloud front in AWS or whatever, and you want to verify your domain, you use that via the text records. Or if you want to have a certificate, you also use that text record for that. So certificates has increased a lot for the last 10 years in usage.
Any other questions? Let's go.
So I don't really know how to repeat this question. Basically, what's the future of DNS? Well, as with all the old protocols like TCP, UDP, DNS, FTP, whatever, I think they will stay because they're such an integral part of everything, how everything works. So if you want to have any kind of backward compatibility or any older devices, they will probably not be able to interpret new protocols at all. And that's basically why we still have these old. They make additions to it, and Google has made this new, where you query DNS over HTTPS, for example, to make it more secure.
Cool. I have a wrap-up question, even in a way. If someone like me, who is completely new to all of this, your introduction was the first introduction I ever heard on DNS, and it was super interesting. Where should I start if I want to learn more about this?
So where should you start if you want to learn more about DNS?
Yes.
Well, in some ways you already are if you're a front-end developer and have a website or anything, because everything uses DNS. But I think the easiest one is if you actually have a domain to play with. So if you either set up a subdomain for GESHDO or you own your own domain that you can buy from a domain register, and you play around with it to see how it works. That's usually the best way.
Sounds great. Thank you so much.
Thank you.
All right. All right. We will take a 5-10 minute break, fill up your pizza, and we will be right back. Now we're going to listen to our last speaker, and it's the Tech Talk's first external guest speaker even. So I want you to, yeah, we sure already. I want you to give a big round of applause for Frederik. Welcome back to GESHDO again.
Thank you, guys. Yes. So let's get started. I have an agenda with me. So what I'm going to be presenting here now is, first of all, the company I'm working for currently and who I am. Then I'm going to get into RxJS, which is the technology that I have taken with me to present for you guys. And once I'm done with that, I'll get into some examples of RxJS in the real world, specifically what we're using it for, where I'm currently working. So first off, who am I? My name is Frederik. For those of you who don't know, I used to work here. That's why I know about GESHDO and why I wanted to come back. So I really liked it when I was here, and I wanted an excuse to come back. So here I am, making a tech talk. It's really nice that I could come. Selling Group, I've promised to talk a little bit about the company I work for. They are a big company in Denmark. They have more than 50,000 employees. They own a lot of different things in Denmark: stores, web shops, cafes, restaurants, department stores. They're currently spread over 3 different countries. They have been in Sweden with Netto at some point, but that was bought up by ICA. They have an underlying vision for everything they do, which is to make the everyday life better for everyday people. They own some international businesses in Denmark, the Danish version of these two that you might have heard of. Then they have a department store that is huge that is called Selling. It's in all the big cities in Denmark. They have BR, a toy store. They have Netto, a discount grocery store. They have Føtex, a bigger grocery store, and they have Bilka, an even bigger grocery store chain. And these 3, Bilka, Føtex, Netto, are what is the primary thing of the Selling Group. This is where the most of the money comes from, these big grocery chains that is spread all over Denmark. Yes, but I'm here to talk about tech. And as I said, what I'm going to be talking about is RxJS. And maybe I thought we could do a raise of hands of who has heard about RxJS before in this room. So a few. And then who has worked with RxJS or is working with it currently. So 1, 2 maybe. As expected, it's I hadn't heard of it before when I started working with it at my current job, but it's a technology that I find very powerful, and it kind of fills a hole in how we work with data, I think. So I thought it would be worthwhile to present it to you guys. Real quick, Rx stands for ReactiveX, and ReactiveX stands for Reactive Extensions. On their landing page, they have this. ReactiveX is an application programming interface for asynchronous programming with observable streams. It's a tough pill to swallow, so I'll do my best to explain what that means if you didn't get it. I know I didn't the first time I read it. So some people on the internet has described it as Lodash for event-driven data flows. And for those of you who don't know Lodash, Dash is a very popular utility library for JavaScript. So it has a lot of utility functions to solve very common issues or problems in JavaScript. And the same way you can think of Rx for data streams, it has a bunch of utilities to work with these, combine these, aggregate them, do all kinds of cool stuff. I will get into the specifics soon enough. And real quick, what is data flows? So a good way to think of it is it's basically any data that emits multiple times over a time period. So any data that changes over time, basically, is what I'm talking about, and is what ReactiveX is working with. How many of you know the pattern observer pattern, or has heard about it before? A few. You might have heard about it in school. I did. But basically, it's this very very used pattern in computer science, which is you have a subject, and then you have 0 up to many observers of this subject. The observers can choose to register as a listener for notifications on this subject, and they can also choose to opt out and stop listening for changes on the subject. The subject can notify all observers of a change. And what it basically does is it has a list of all the observers currently, and when there is a change, it loops through them and notifies all of them by calling some kind of function on all the observers. And the reason I mention this is that in Rx we have a construct called observables, which is the very foundation of everything in Rx. And this has very much, it is very much like observer pattern. The observable in Rx is basically the subject in observer pattern, but extended with more things on top. I'm going to get into that now. Next slide. And the last thing is this framework ReactiveX is implemented in all the big languages. So I'm going to be talking about RxJS, which is the JavaScript implementation of the library. But it is also implemented in all the other big languages. So don't worry if you're not into JavaScript like me. There you can find your implementation that fits your needs. So I said that the observable in RxJS extends the observer pattern. So the observer pattern, you can only notify the observables of changes. What the observable can do more than that is it can notify observers that it's complete. So it has one more callback that is completion. So it can tell the observers, hey, by the way, I'm done emitting stuff now. You can do whatever you want to do based on that information. And the next thing is it also adds in error handling, so it can also notify all observers something went wrong, and then with that comes some kind of error message like we know of, and the observers can of course react to that accordingly. So these two things alone already makes the observer pattern much more powerful, and it's very important to have that in when you're working with some streams of data. So it's really nice to have it, but in many cases we actually only work with the notify callback anyways. But what really takes RxJS above and beyond and makes it so super powerful is the introduction of operators, which is, we know operators from other places in programming, like logical operators like AND and OR. We know operators from lists, in JavaScript at least, and also in many other languages. We have operators like map and filter and reduce and sort, these kind of things that take an array, you apply the operator to it, and it performs some kind of arbitrary transformation or aggregation on the list and returns a new list, at least when we're speaking of arrays. And the reason I talk about arrays now is that when we talk about data flows, data streams, we can see them as lists as well. It's basically a list of data, but instead of having everything available immediately, you have the data available over time. So it comes in, over time. But because it is so similar to lists, we can do some of the same transformations on observables as we can on lists. Therefore, we have operators like map, filter, and scan. And these are really good when you start out with RxJS, because many of the others can be kind of hard to understand in the start. So it's why I highlight them here. If you're starting out, these are really good to kind of play around with and get an understanding of how it works before diving into the rest. So I also have some other operators here on the slide. The reason I have them here is just to showcase the ones I use the most. I'm not actually going to go in now to exactly what they do, but these are 8 operators. There's more than 90 operators in RxJS, and that's what makes it super. It has a super steep learning curve, and it's because when you read other people's RxJS code, you see these long chains of operators, because you can apply an operator, multiple operators to an observable in like succession of each other, just like you can with arrays. When you dot chain, you say some array dot map dot filter dot sort. You can do the same with observables, and that's basically how you work with them. But it can be really hard to understand other people's code, because how are you supposed to know these 90 different operators? But don't worry, if you're starting out, start out with these, and that makes it easier to swallow. You don't need to know all of them when you start out. Here I have a visualization of how similar an array is to an observable. So here we have an array, we have 4 values in the array. Here we have an observable, it emits 4 values before it completes. And you can see visually, we can represent them kind of similar. Where the only difference is on the observable, there is a variable distance in between these values, which represents time. And there can be no time in between. They can come synchronously right after each other, but there can also be longer time in between them. And that's because we work with data that comes over time. And here I have kind of tried to sum up the power of RxJS. And it is that we can treat streams of asynchronous data as lists, like mentioned. We can perform arbitrary transformations and aggregations on these observables, which makes it really powerful. I'm going to demonstrate in a bit. And yeah, lastly, we can combine multiple of these operators to unlock real power. But enough talking. Now let me show you the power of Rx. I have made a little example here. I hope you can read the text. See if I can point with this one. I don't know. Maybe not. Okay, so I hope you can see the line numbers. So here I have a demo I created that is a drag and drop functionality in the browser. On line 6, if we start here, we have something that web developers will be familiar with. It is a query selector that selects an element on the screen with the ID target. So now the target const here, the variable target, has a reference to this node in the DOM. Then next up we have line 8, 10, and 12, which kind of does the same thing, but this is where we start doing some Rx stuff. They all are variables that are created using a utility from RxJS, from event. And what from event does is that it takes a target and then an event. And events are these things that we have in the browser that can happen on any DOM element. And it takes these things and turns them into an observable. And like described, an observable is a data stream. And what this data stream contains is events. So whenever one of these events happen on the given target, this observable will emit this. So now you can subscribe to one of these observables. Whenever this event occurs on the given target, you will be notified and you can react to that accordingly. So that's already kind of useful if you just need to trigger some event. Whenever you click on a target, you can use the first one, subscribe to that one, and in the callback, describe what you're going to do. But to really showcase the power of RxJS here, I have gone ahead and used some operators on them, on our 3 observables here, to create a 4th observable, which is drag and drop. So I start out by taking the target mouse down observable, because this is where we want to start our stream of events. When the user clicks on the target, we will start listening for events because now we are starting to do our drag and drop functionality. So there will be emitted a value when you click on the target. And then we start with the first operator, which is switch map. I'm not going to go into detail exactly what it does, but we can say for now that it just switches from one observable over to another. So you click the target. Next line, you start listening to another observable, which is the mouse move. So once we have clicked, we start emitting events whenever the cursor moves on the screen. Then on 16, we map the event to another object. The event contains a bunch of data. We only really want to, we're only interested in the X and Y position of the mouse. So I map it over to a simple object with only an X and a Y property. So that is now what will be emitted from our drag and drop observable. And then line 17, we tell it when to stop. So until 16, we're only listening, we're listening to all mouse movement on the page, but we also want it to stop at some point, and we do that by saying take until there is an event on the mouse up observable. So our last observable here will emit when you release the mouse on the document, and we are now done listening. We have now moved our object on the screen, and we are no longer interested in listening to mouse move events. And that's it, basically. Now we have the functionality we need. But I wanted to be able to repeat this functionality once again. So I have used kind of an intuitive operator here that's called repeat, which just says instead of completing this observable, go ahead and resubscribe to the source. So what we do on line 18 is go back to the source and resubscribe to that, and now we're again waiting for a mouse down event. So now we have our functionality, and it can be, we can do it multiple times. But observables don't actually do anything until we subscribe to them, which is really performant because no code will be executed as long as no one is subscribed to them. But of course, we want some cool stuff to happen, so we subscribe to our observable here, and we say we give it a function, which is what will be executed whenever there is a new emission in this observable. And what I do here, I unpack the X and Y value that we get from the event, and then we update some inline styling on the target, the same target that we are listening to mouse down events on. Yeah, we just update the position of our node with that. And then there we have it. Done is, of course, the target node. So, of course, there's some HTML as well that goes with this and a little bit of styling. And done is just a text element that has the ID target. So that is what we're listening on. Yes. So now you have seen RxJS in a simple example, or an example that tried to just showcase what can be done. But of course, it's also interesting to see what we're doing with it at bigger scale. And yeah, so I'm just going to present what I do in my job. We're building this application that is called Vertex Home Delivery. It's just a home delivery application. We have a website. We're currently working on an app. It's built in React. We have kind of a sophisticated setup for our front-end application. So like you saw, Selling Group has a lot of different formats, a lot of different stores. So of course there goes a lot of different applications with that. Vertex alone has more than 5 user-facing applications. So that's a lot to manage. And as a way to combat that, we have a lot of duplication. We want to, of course, build reusable packages. So we have started to implement this monorepo structure in our application, which means we can have a lot of independent packages and we can use them across multiple applications. And we have started doing this, and we have made RxJS the backbone to all of it. And this whole monorepo setup could be a whole talk for itself, but I'm just gonna talk about the part that is RxJS. So we have this layered structure. We have an API layer in the bottom. We have what we call a service layer above that. So those, the light blue down there are packages that is in the API layer. And then we have a service layer, which is the darker blue. They're all independent packages, and that means we could, if we wanted to, publish them to, for example, NPM or any other package registry, and then you can take them into your application. In Node, we do it with package.json. Similar things other places, of course. Then we have another package that is a service adapter. We are building our applications in React. So we have a service adapter for React. We also have one built for Vue because we have other applications in Vue. And all this adapter does is basically take all the RX stuff and wrap it in some framework-specific functions, so it's easily consumable in the framework that it's used in. So for React, we are using hooks to make it very easy to work with. If we walk through the layers real quick, is that example of what things from RxJS we use in every layer. In the API layer, we use a function in from RxJS called Ajax, which just is the observable way of making a network request. So instead of, for example, getting a promise, if you know that from JavaScript, with this we turn the request into an observable that will emit a value once the request returns. If the request somehow has an error, instead there will be emitted an error. Then we use the map operator to map it to a unified format. We have some really powerful operators in RxJS to work with retries and bounds and caching and all this kind of stuff. We do a lot of that in the API layer to get better performance in our network requests. Then our service layer, that kind of uses all these APIs from the API layer. And it's also here we have all of our state. So in RxJS, we have something called a behavior subject. It is basically an observable that holds some kind of initial value. So our application has a lot of state that needs to be shared between many different components. In our service layer, we keep track of all this state. So we use that, and then you can listen to changes in the state and react accordingly. So you can basically say we have this big piece of state in the authentication, for example, package, and in the app you want to subscribe to that, for example, to see when the user is logged in or not, and then when it logs in, you can react accordingly. Yes, I'm not going to go into the details here. I think I've been talking for a while. Real quick, we have use observable in the adapter, like I talked about. This is an example. If you don't know React, maybe this is not so... maybe you don't recognize this code very much. If you have worked with React, maybe this is familiar. But it's just to showcase that we have... we're working with RxJS by subscribing to the observable, and then we're turning it into what's called local state in React by calling set state, set value, whenever there is a new value emitted from the observable, which is just one example of how we're turning RxJS into framework-specific, easy-to-consume code. Yes. And with all the magic we've done behind the scenes, it's so simple that when this is an observable that changes over time, so are you logged in or not, it can switch anytime, but the way we use it in our front-end code is just consuming it as it was a normal variable. It is set up as state in React, so it's reactive. It will trigger a re-render in our front-end application just like that, and we don't need to do anything else. But behind the scenes, it's all running on RxJS. Yes, that was all I had. that's my application. Oh, that's my presentation. Sorry.
Good.
Yeah, so question is if we're running RxJS on all of our packages, I guess. And the question is yes. That is one of the few things that is a dependency in all of our packages, because it is the central backbone to how we have structured our whole monorepo. So yes.
Any other questions? Did you have one more?
Yes. Should I bring it up or? Okay. Yeah. Yeah. Question is if there is a performance gain by just switching, like in the example, to RxJS and using the from event utility from RxJS. And in my example, actually no. What we're doing is the exact same as just setting up a listener that updates the state, because that is what the from event utility does. But RxJS comes with a bunch of operators, like I said, and these operators can help you throttle and do many things like this to optimize the code. So I would say no, but you can use the operators to definitely achieve much better performance. Yeah. Yeah.
Cool. And Kasper?
So the question is if it's a big bundle, if we are suffering from having a lot of extra stuff in our bundle by using RxJS. And I actually don't know the size of RxJS, but I do know its bundle size is something we care about. So I don't think it's a huge problem, and I definitely think the benefits outweighs the cost in that sense for us.
I was wondering, because RxJS is at, I think, version 7 today, and it was in the version 5 that it made its biggest jump, basically. What do you see in the future for RxJS? Do you see anything specific?
I'm honestly not sure what is coming in the pipeline. To be quite honest, I don't see myself as quite an expert on RxJS yet. I don't know, honestly.
It's a tough question.
Yeah.
Definitely. So, let's see. Yeah.
So question is if why we decided to go with a monorepo if it's specific to, if it's because of RxJS or not. And no, it's not because of RxJS. The monorepo decision comes from having, I don't think we have 50 different applications in Selling Group right now, and we have a lot of duplication and different apps for the same store that kind of does the same thing. So the monorepo decision is to avoid duplication and being able to build these packages that can be reused.
Axel?
Yeah. question is if there, when I'm working on with RxJS daily, if there is one operator I wish they had that they currently don't. And I would say so far, no, it's more the other way around. I'm like working with my observables. I'm doing some janky stuff to get it to work, and then afterwards I realize, oh, there is this operator that does exactly this. Yeah,
Classic.
yeah.
Cool. Any other questions? In that case, thank you so much, Frederik.
Very welcome. Thank you.
So, and with that, we are reaching the closing of our 4th Tech Talk. And I would like to extend yet another thank you to our presenters who came here today to share knowledge with us. Thank you so much. And sure, I agree, one more. And also, I would like to extend a massive thank you as well to the project group that has put the entire tech event together. And thank you so much for giving us a forum to share our knowledge. And yeah, it's been amazing hosting this event. Thank you so much. And with that, I want to thank all of you for coming. And I hope you have had a great evening and will have a great night. Thank you so much.
Thank you. Have again.